Welcome to Summarize Science. Have you ever wondered what causes a galaxy to suddenly stop producing new stars? Astronomers are now using artificial intelligence to solve the mystery of why some galaxies remain vibrant while others go quiet. The researchers behind this paper use data from a massive cosmic simulation called TNG 100, which models the evolution of the universe. They looked at over 6,000 galaxies and divided them into 63,000 smaller regions to get a high-definition view of what is happening inside them. To process this mountain of data, they used two powerful machine learning algorithms known as Random Forest and XGBoost. By analyzing these spaxel bins, the AI was tasked with predicting two things: whether a region is star-forming or quenched, and exactly how fast new stars are being born. This spatially resolved approach allows the researchers to distinguish between local effects happening in a specific neighborhood and global effects affecting the whole galaxy. They even accounted for the fact that some galaxies might not have a central black hole yet, ensuring the data was as accurate as possible. One of the biggest discoveries was that star formation is a very local process. The AI found that the number of stars being born in a specific spot depends almost entirely on the density of stars already there. This confirms that as long as there is enough gas and mass in a local area, stars will keep popping into existence. However, the process of quenching or turning off star formation is a completely different story. Unlike star formation, quenching is driven by global factors that impact the entire galaxy at once rather than just one small neighborhood. For large galaxies sitting at the center of their cosmic web, the mass of the central supermassive black hole was the number one predictor of whether a galaxy would stop making stars. This suggests that black holes act like giant engines, pumping out energy that heats up the surrounding gas and prevents it from collapsing into new stars. When we look at smaller satellite galaxies, the story changes again. For these smaller neighbors, the most important factor was the mass of the dark matter halo they live in. This indicates that environment plays a massive role for smaller galaxies, likely through a process called ram pressure stripping, where their gas is literally blown away. The study also highlighted how different AI models can give us different perspectives on the same data. While both algorithms agreed on the top factors, XGBoost was better at showing how several related properties work together. The researchers also used a traditional technique called principal component analysis to double-check their AI findings. This mathematical check confirmed that local variables dominate star formation while global variables dominate the shutdown process. It is a powerful example of how modern computing can confirm theories that astronomers have debated for decades. To recap the most important points, stars are born based on what is happening in their immediate vicinity. But the death of a galaxy's star-making ability is decided by big-picture factors like its central black hole or its cosmic environment. This means that to understand a galaxy's future, you have to look at both the tiny details and the massive structures surrounding it. In the future, this research will help create even more accurate simulations of how our own Milky Way evolved. By bridging the gap between computer models and real-world observations, we are getting closer to a complete map of cosmic history. Thanks for watching Summarize Science, and don't forget to stay curious.